Hey there, this is Debesh, the info security researcher. Today, I am again on an webinar, live webinar, straight to LinkedIn Live and YouTube Live. So, the topic is written on the image player, the biggest risks of biometrics. So, I have just checked few minutes pause, probably you have seen me. So, I hope that you are able to listen to my voice and see the video. I'll be first presenting one PDF file. I do presentation using PDF file, not Windows or any other PPT. PPT is actually, I don't like it. I don't like using proprietary software. I use GNU Linux and open source software. And I prepare my presentation using LaTeX, and it is in a PDF mode. So let me open the PDF file and share with you. Okay, please hold on for a minute. Let me share the video. You see the first page, the title page of my presentation, biggest risks of biometrics, inconvenient truths of biometrics recognition technology. I hope you can see it. Being shared. Yes, you can see it. Okay. And so let me start the presentation. The subject is okay. I'll make it a full screen. Hope it will also work here. Okay. So it is actually a story of pattern recognition, a story of unreliable pattern matching. You can see it here, unreliable pattern matching, which we call biometrics authentication, the human and personal identification and matching. So this is a webinar straight to LinkedIn and YouTube live. So what are the contents? Okay. This is actually the scheme of my presentation, the outline. I will discuss first about pattern recognition briefly, and then about biometrics, a little bit about my research, the background, where I come from, and how I come into biometrics pattern recognition. And before that, yes, my research is extended to 3D object recognition, and I have applied the 3D object recognition to 3D human face recognition, which is an application which you find in the um, iPhones, which was launched in probably 2011 or 9. I don't remember exactly. Okay. So my research started long ago. Many years ago, Apple launched iPhone with 3D Face ID. So it also works with the same principle. In the phone, there is a projector. So it works. I mean, I will explain while presenting. So then I will tell about some problems. What are the problems? And why the world is still going on using the text password. There is a question, big question. If biometrics is so good, why? Why texts are going on for all the platforms as a default authentication technology? And also, I will give some a short glimpse about if there is any alternative thing. If you ask me, I will also propose, I mean, show some alternative way, which will be even better than text passwords, or biometrics is ruled out for me. And it is a biometrics rush. I call it biometrics rush because they're rushing with biometrics, saying that it is good, it is good, it is good. But what it is good, they are not telling. So at the end, I will give you some chances to ask questions. So pattern recognition. What is pattern recognition? It is recognizing the objects and the surroundings environment, which is very trivial task for humans. You know that we recognize humans, our friends, our mothers, our parents, objects like, say, this is a table, this is a book. So how do you do it? It works in the brain. Our camera means the eye senses the information, it processes inside the brain, and there is a huge processing. Yeah. So, but that processing is so fast and so good. It appears to be trivial, but it is a huge task. The human is performing there, and the pattern recognition, whatever we are doing, it is a pretty complex task for machines. So machine is trying to mimic what we do in our brain and computers. And machine means it can be, say, some mechanical machine also. I earlier say before the computers came, it was a uh, tried with computational method. I mean mechanical methods or touching methods for that. So pattern recognition involves developing complex algorithms and considerable computation tasks. So how it is done? The objects or the patterns which are sensed using acquisition system, a camera, and then it is pre-processed primarily inside the computer machines, and then the algorithm is executed, and finally we get the inference, means whether it is recognized or rejected. Pattern recognition can assist solving various inferences problems in biometrics, bioinformatics, document classification, image analysis, data mining, industrial automation, biometrics recognition and authentication, which is the topic of today, remote sensing, handwritten text analysis, medical diagnosis, speech recognition, GIS, and many more. Pattern recognition depends on mainly on the amount of data, the technology, and the designer. The designer we are actually uh, showing there. So the designer and the user, and the designer of the user. Okay, so okay, it has gone here. Okay, and let me show the complete thing here. Yes, designer and the user, and pattern recognition uses statistical structural template matching, cross correlation, neural networks, etc. techniques. Sorry for the technical glitch. I was not having that keyboard was not working here. Okay, so the next is the optical character recognition, which is very important application of pattern recognition. So when we learned optical character recognition, OCR, popularly termed as, in a course in holography in the first year of our masters in applied physics. And the scheme was like this. So input filter is there, it is being convolved, and let me check the, yes. The figure A is the block diagram of an optical character recognition system. B is optical realization of matched filtering for optical character recognition. And figure C1, 2 are the filter impulse response and the output response. Uh, yes, I am from the optics background, so I started this pattern recognition from optics actually. So it is a optical pattern recognition system where the lenses perform optical two-dimensional Fourier transformation. What Fourier transformation also are done now when regularly on computers using fast Fourier transform algorithms. So this is the input function. Input is this 3 letters QWP, and this is the filter function, which is this one, and input is only QWP. I mean, not only, the spot is actually the result. So this is the output plane. In the output plane, we see that where P is, we get a sharp dot, and the location also where it is. So it is a very nice application of optics. The reference is Introduction to Fourier Optics, second edition, J.W. Goodman. The idea of optical character recognition was clear after doing van der Lubbe correlation experiments during our PhD. Means this we studied, but it was not very clear before we did the experiment using, at that time, yes, in the 80s, late 80s, 88, 89. So we used holographic plates, silver halide holographic plates to record the matched filter and also implement the experiment. Optical character recognition has applications in automatic printed handwritten document to text conversion. It is regularly done nowadays, which also is now empowered with AI. So biometrics pattern recognition. Biometrics are automated methods of recognizing an individual based on measurable biological, that means anatomical and physiological, and also some behavioral characteristics or traits. It includes fingerprint, facial features, iris patterns of the eye, voice, hand geometry, palm vein patterns. It is here, palm vein pattern. I mean, palm vein pattern is inside actually. It is, we have to use some infrared sensor to capture it. Hand geometry is outside. And gait, like such as the walking or typing rhythm, the keyboard stroke dynamics, which is a technical terminology. Even body odor are also, like sweat odor are also some characteristics which are different for different humans. Biometric system can operate in one, verification, that means authentication, which verifies person's claimed identity via one-to-one comparison, and two, identification, which determines an individual's identity through a one-to-many comparison in a database. So this is a example, like say somebody's name is there, and the person is trying to authenticate, like verify her identity, means verify her login using fingerprint or face. And this is one-to-one, and this is actually that identification. The case 2, where one person which the face, say here it is this, which is matched with a database of many faces, and it is identified that this is the person and the name is this. It is a slightly more intensive computation than verification. How biometrics recognition works? In principle, many of you know, but I will make it complete so people who are not knowing, they also can understand. The significant features of a face consisting of the nose, say it is for example of face recognition. The significant features of a face consisting of the nose, eyes, and their locations are utilized as a metric to distinguish between faces of different human subjects. The accuracy of recognition greatly depends on illumination, skin color, orientation, size, the scale, rotation, etc. parameters. The accuracy of recognition is always less than 100% and can be lower, 97%, 98%, 95%, or even lower, depending on the condition of face image capturing. And text passwords work on the principle of comparing the stored hash, MD5, SHA1, etc., of the text passwords with that of the text input text streams by an XOR operation. Text passwords yields either matching if the stored hash matches with that of the input text streams, which is now the passwords which we are inserting, or rejection if the hash patterns don't match. So my research in pattern recognition. My interest of pattern recognition grew while working in the government R&D lab, DRDO, mainly in correlation pattern recognition, because they had some projects. So those were recognizing 2D patterns and images using joint transform correlation. But the real world is full of 3D objects that asks for developing 3D object recognition system. I implemented 3D object recognition by combining correlation pattern recognition in Mitsuo Takeda's by using the Mitsuo Takeda's well-known and well-tested Fourier transform profilometric 3D sensing system. This is Professor Takeda introduced it in the 80s, early 80s. I applied the new 3D object recognition technique to 2D human face, 3D human face recognition, and obtained satisfactory results, because three human faces are basically a three-dimensional object. So I used that for recognizing 3D human face objects. I experiment the system with pose and orientation variation of the human faces. So 3D face sensing and object recognition. Briefly, I will show the work I have done, a part of the work I have done in Professor Mitsuo Takeda's laboratory in the University of Electrocommunications during, say, in 2001. So the first figure on the top left-hand corner, it is the experimental setup where two objects blocks, object 1 and object 2 are there, which are illuminated by a grating pattern by a projector, which is having an angle theta. And this is the camera system which captures the image from the top. And these are the actual photographs, A and B, of the two object blocks. Both are flat, but different height. And the smaller object is in B, which is used as the target to be recognized. And C shows the pattern projected image captured by the CCD from the top, orthogonally top. And D is an exaggerated, like a amplified image, so that you can see that the patterns are projected on the object. And That is a shadow because it is illuminated using an angle. And figure E are the computed phase map as per the modified multiplex Fourier transform profilometry due to Professor Taketa's technique. And this is E is for the two objects, like it is captured here, and F is for the target, like for here. And G represents the correlation peak, the recognition of the object in the correct place where it is. And H is an erroneous result when we don't actually modify the Fourier transform profilometry. I have modified it using two grating patterns multiplexed in angle and projected onto that. So this is the title of the paper, Frequency Multiplex Profilometric Phase Coding for Three-Dimensional Object Recognition Without 2 pi phase ambiguity. It was published in Optics Letters in 2002. So I have applied this technique for three-dimensional human face recognition. The top left-hand corner is actually the setup of the experimental arrangement. You can see schematics. This is say the human which is standing behind the wall, and this is a projector projecting a grating pattern, and this is a camera orthogonally capturing the image, and it goes to the computer and processed. So A, B, C, D shows grating projected human face images. A and B for particular person. B is slightly rotated, you can see, and C and D are for the same. And E, F, G, H are the corresponding phase map for say A, B, and C, D. These grating projected images. And I shows the correct recognition. Say if I correlate with the phase map of A with phase map of B, it will correlate and give a sharp peak. But if we correlate with say any one of A and B with any one of C and D, it will give a noise like output. So it is rejected. So this is actually the title, Three-Dimensional Human Face Recognition, which was published in Journal of Optics in 2009. That year it was actually the top downloaded paper in that journal, which is published by Springer. So I have made a research decision, very tough research decision. I have worked on biometrics for more than 10 years, almost 14, 15 years, 15 years. But I now discarded biometrics recognition. Why? I was not satisfied with biometrics recognition technology. There were various reasons. First, biometric recognition is probabilistic. Like it is either say 97, 98%, but it is never 100%, and not deterministic, like text passwords or pins. And so biometrics cannot yield a deterministic yes/no result like the text passwords. Biometrics is spoofable. You can make spoofs of fingerprint, face, IDs, everything spoofable. And the spoofing technology is progressing at an alarming rate. The criminals are actually improving it. And in fact, the biometrics recognition, say face recognition itself, the results that say invariance face recognition for different illumination and say illumination invariant face recognition, this gives actually helps the criminals because say it is slightly different because the proofs are not exactly the same, and even then it can recognize because of the invariant recognition techniques developed by the researchers. I mean, through many papers and patents. It is an irony. Biometrics can be copied, collected from the public places and social media. It is true, like people upload high resolution images in the social media, and in public places also people can access it. Say somebody is it can be also stolen. Say somebody is touching a glass while drinking water or drinks, so the fingerprint is imprinted there. It can be collected using some technique. So biometric data once stolen, this is another reason. Biometric data once stolen, hacked, or lost forever, because biometrics cannot be reset like the text, passwords, and PIN. That is what actually that in the biggest risk it is written, that irreversible leakage of biometric data means once it is leaked, you cannot actually reverse it. Biometrics have finite false acceptance and false rejection rate. What is that? It is actually that whatever it is written in the post, say the misidentification. Misidentification means, say you are the person and you are posing with your face or fingerprint, but it rejects you. It rejects you, false rejection. And false acceptance means, say somebody else, a third party, is posing with the face or say with a spoof, it gives entry recognition. That is a false acceptance. That is actually called, say, misidentification. And it is written there, it is a potential misidentification. It is a potential risk. Biometrics is having credential stuffing issues, which means credential stuffing means using the same password or authentication token for many accounts. Say you are using the same text passwords for all the accounts. Say your email, your bank, many other financial, credit card, everything. So once the criminal gets your password, they can have access to all accounts. So in biometric, it is the same thing. You have to use the same biometric. So it is inherently, it is a credential stuffing. That means using the same password or authentication token for many accounts. So biometric spoofs are easy to make, and it is progressing at an alarming rate. I can tell you one story, means it is an incident in 2017 in Mumbai. There is an institute called University Department of Chemical Technology, a big institute. Now it is a deemed university and probably an university now. At that time it was deemed. Now it is university, and there they use fingerprint for attendance registration. So teachers found that physically there are less than 50% of students present in the class, but the system registers more than 90% attendance. So what is the reason? The reason is that the students, they used fingerprint spoofs, and the spoofs, say one student bring 12, 13 friends spoofs and gives the attendance, the fingerprint sensor, and it is recorded. So that is how it is. It is so easy to make the spoofs, and because they are from chemical technology, they knew how to make the spoofs. They use some 10 rupee overhead transparencies, like thin cellophane paper, and when it is heated and you just press your fingers, then it gets the imprint, and it can be attached to any, say, round thermocol or some object, and it can be used. So criminals are looting people's bank accounts using fingerprint spoofs. In our country, yes, in India, Aadhaar enabled payment system. Aadhaar is the digital identity system of India. They boast of, and they have biometrics for authentication. And they have added another problem. They have made it mandatory to use all the bank accounts to use Aadhaar enabled payment system. That means they can use Aadhaar number and a biometrics, and they can withdraw money. So these looting are done regularly since 2017, when Aadhaar was not mandatory. After that, in the Supreme Court, it has been made mandatory, like, say, for voting. Say, three panel judges were there. Two judges told that it is accepted, it is okay. One judge told that no, it is not okay. So anyway, so what happened in last year also in Kolkata, that so much this type of looting happened. The Commissioner of Police of Kolkata asked people to disable biometrics in Aadhaar to stop such looting. And people don't know that actually, because say whenever they open a bank account in India, by default Aadhaar enabled payment system is active. So it is very, very risky. But people don't know how to actually deactivate. So police commissioner urged people to take action and deactivate biometrics in Aadhaar so that this looting, even they have the spoofs, they cannot withdraw money. The same biometrics for all online accounts. That's I just told. Same biometrics for all accounts. Once biometrics is stolen means all accounts are in the hands of the cyber criminals. Now, this is a question. Why text passwords pins are default in banks and credit cards, all the financial systems? If biometrics is so good, why they are not making biometrics as a default? Why? Why are the banks and financial platforms keeping text password security as a default authentication factor? Why don't banks make biometrics as the default authentication factor? This is a question. The reason is why? Because the security professionals very well understand that biometrics is unreliable and can lower securities. That is why they are using it as a default, as a optional thing, parallel. The banking sector understands that text passwords are more secure than biometrics. That is why they are still continuing the text passwords and pins. Okay, now an alternative solution, we are actually working on it. It is graphical authentication security. So how did I start it? In 2019, I connected with Hitoshi Kokumai, the founder of Mnemonic Security Incorporated Japan, a pioneer of expanded password system, EPS, that accepts both text and image passwords. Unfortunately, Hitoshi expired last year, but he pioneered this system and he started the company in UK. So I quit biometrics and worked with Hitoshi Kokumai on graphical passwords and extended password system. In 2021, Hitoshi Kokumai founded the global company Mnemonic Identity Solutions Limited in the UK and initiated conversion of the Japanese EPS software into English. So I am associated with them. I joined advisory board of Mnemonic Identity Solutions Limited and contribute for EPS software and business development. And what is EPS? Just a view. Say you have a matrix of many images. So you can select 1, 2, 3 or some images, click, and correspondingly it will generate some very complex hash and it will be used as a password. So you can test it in our website, Mnemonic Identity Solutions. The web software is freely available. You don't need to log in, create a login. You can just check it and see how it is working. So biometrics is actually having a limited use case, very limited use case, where it is okay to use. I should not say good, it is okay to use. Biometrics has a very limited application such as access entry control with human staff to support in case of problems. Say in a office entry gate, you can install a fingerprint recognition system or a facial recognition system because there are some staffs are there. So if there is any problem, it can be because say your fingerprint is fading, so you may not recognize by even multiple trial. I have seen the old people, they are not getting their pensions in the Indian banks because by default they have used that fingerprint, biometrics using Aadhaar for withdrawing their pension. So they are rejected and they are getting problem with that. And the bank staff are not actually telling them to opt for the traditional say check system because old people they are very used to using check and withdraw money. Instead they are saying that okay, you just go to the downstairs the server room and uh, re-entry your re-register your biometrics. The foolish thing. Okay, so these are the problems. And government regulators utilize biometrics to track and control the citizens in a crowd. Yes, they can. They can do it. If there is an error, no problem, because it is not actually doing any financial transactions where deterministic result is required. Police departments use biometrics as an additional information for identifying criminals, though it is not accepted in the court as the only evidence, but it is somewhat helping to get the information, additional information. But in all these use cases, above use cases, say for access entry, government tracking, and police departments using biometrics, they don't actually require any accuracy. Like the accuracy of biometrics recognition does not matter in these applications. So I think it is rushing with biometrics. The tech community is rushing with biometrics deployment for authentication tasks. Listen, you can ask me why. The big tech companies have invested a huge amount in biometrics, and the biometrics companies also. They are actually an accessory. I mean, they are working as allies with them. That is why they are pushing biometrics in every platform. They are saying that use biometrics. Biometrics is convenient, of course, but it does not make any sense that they are not saying that it, sometimes they wrongly say that it improves security. That is completely false. Biometrics is convenient, 100% convenient. Say you pose your face, you just put your finger, but it can lower security. That you have to understand. Convenience and security ability bear an uncertainty relationship. You know that Heisenberg's uncertainty principle. Like you cannot measure both, say, uh, momentum and the position accurately. If you measure one accurately, the other is completely lost. So I related this in this work. So if convenience, this graph shows the convenience in the x-axis and the y-axis is the security ability. So say a point of high convenience, slow security, and a point of high security ability, low convenience. So it is a truth. You have to accept it. So think over it, whether you will go with biometrics as the default, if say the companies ask you to make it default. So ask if you have any questions. I am debeshchoudhury, the information security researcher. Connect with me at LinkedIn and explore my work. We can cooperate and collaborate on subjects of common interest. Okay. So in the chat, it is not showing anything. I don't know whether somebody has asked anything here. Anyway, I just presented this in this webinar and it will be saved on LinkedIn and YouTube. Let me check YouTube before I close it, and hopefully it is streaming. Yeah, it is streaming. Yes, it is streaming. And if you have any question, you can write me. You can connect with me. If you are not connected with me on LinkedIn, you can connect with me. You can write comments here or on YouTube. And I'm stopping the share, and we can contact. We can have questions. So still I have time with the webinar platform. It is 1 hour maximum. So it is showing about 50 minutes I have utilized. So anyway, if you like to ask any question, you can of course ask me here using the commenting system in LinkedIn and YouTube, or You can also log in here if you like to. I don't know whether anybody has logged in. No, nobody has logged in. But anyway, this will be saved on LinkedIn and YouTube. You can, of course, ask me later. You can view it later. It is there for you. I mean, I will not delete the videos on LinkedIn and YouTube. So you can watch it later at your convenient time. Okay. So that is all. And I hope I will stream more live sessions and my technology podcast, the tech podcast in Learning Times podcast. It will carry on. And last Saturday, we have featured Professor James Cole and Dr. Shashwati Banerjee of Photonic Wave Solution. The title of the mini workshop was, the first part of the mini workshop was uh, the introduction of computational photonics. The mini workshop entitled Computational Photonics, the part one was introduction, which was streamed on last Saturday, 6th December. And the coming Saturday, 13th December, there will be another episode, the second episode. So I hope we'll join. We'll schedule the uh, podcast soon, maybe today or tomorrow. Okay. So be there and take care and think about whether you will adopt biometrics or not. There are huge risk using biometrics because do you want to lose money from your bank account or your credit card system? And don't go for convenience. Give importance to your security aspects in the digital domain as well as say while entering into the office or other things. I mean, you cannot actually command the office staff, I mean, organizations to use other authentication methods. But at least for you, when you are using your credentials for say banking and financial systems, don't accept biometrics. Okay, see you, be there, and okay. So I will end the stream. It will be okay from here. Okay.